Good morning, everybody, all you wonderful humans, and in particular to Austin and everybody who's just jumped across from Austin's stream. I was just there watching Austin assemble some boards, and he wrapped up his stream about 2 minutes ago. He failed to let out any magic smoke though, so maybe we'll have better luck and I'll let some smoke out today. That could be fun. First, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. It's actually really disconcerting having just gone from watching a live stream and chatting to now I'm doing the live stream and watching. Oh, it did smoke, says Austin, and now the roles are reversed. Austin is chatting in my stream. So good morning to everybody. Sharky, Chip is here, Gerald, DIY, Peter. Oh, Peter is calling for Steve. Steve and Steph. Steve is here. Steph is here. However, I am not feeling too charitable about them right now because we have a big possum problem in the factory. We've got a brushy tail possum, like a really big one, and there's been causing havoc, getting into bins, ripping stuff up, making a big mess everywhere, and also a couple of ringtails. And it's been quite a mess in the factory over the last few days. In particular, they've been going on a rampage and getting into everything. And anyway. So, who else was here? Oh, that's right, I was in the process of saying good morning to everybody. I got as far as Peter, Stephen, Chris is here, Michael, Gavin, some call it fun, Luminator, Don S, Amanda, Aaron. Yes, Aaron was just in the chat on Austin's as well. Russell, Gerald, David, Alexi, BFits58. So BFit says, best wishes to all from the UK, 1 AM here, so I'm just off to bed. Okay, well, thanks for saying hello at the start anyway. Paul Schultz is here. Excellent. The Lane. Justin C. Keith H. Yes. Tourist. Tony, Celtic Beast. We've got so many people here today. Lots of people. Also, I just saw Keith in the chat, which reminds me that the barbecue last Sunday? It feels like it was at least 2 or 3 weeks ago. I've got totally twisted around in my sense of time and what the date is. What is it? It's the 7th today. So yes, I think it was last weekend. It really does not feel cable tie. Like it was last weekend. So, the reason that Keith's name in the chat reminded me of that is that Keith is the patron of the barbecue. It's Keith's barbecue that we used last weekend. Well, Keith donated it to the cause, so thank you very much for that. And I had a lot of fun. It was much busier than I expected. I had a couple of people from the gym come along as well, and a few other people I know from around the local maker community, plus live stream viewers, obviously. And I think some people came at the start, some people came towards the end. So there were quite a few people who were here at different times and didn't even see each other. I think overall about 25 people or so were here, so that was good. Yeah, the source machine, says Aaron. Yeah, SourceBot. The world famous SourceBot was here. It was great. Yes, Cable Tie says the source machine was fun. Yeah, the very first SourceBot was made out of an old Mendel 3D printer, and the first SourceBot is actually in the back of the factory here, but it hasn't run for a couple of years. The pumps never really worked properly because they couldn't deal with the thickness of the sauce and the mustard, and Andrew Nielsen designed new types of peristaltic pumps to be able to dispense the sauce, and it all worked really well. Okay. Oh, Chip says buffering here. What? Already? That is terrible. Hang on, I've got to get my console up so I can see what's going on. According to the YouTube console, it doesn't have a particular problem, but hopefully... yes. Yeah, Chip, I think it might have been local. Yeah, so there are a bunch of people in the chat here this morning who were at the barbecue last weekend, and it was really cool to see people in person. So Cable Tie says, I've been showing a video I took of the sauce bot to anyone who'll watch. Cool. Is that video public anywhere? Is it somewhere that we can link? Maybe on Twitter or Facebook or whatever? Yeah, Aaron said it's just the possum chewing on the internet cables. That's right. So it's not Steve and Steph. They're being good. They're sitting here beside me. Now, before I get into doing assembly, a very quick update on... I've just got to open a directory here. I've got to go into Dropbox and look at camera uploads. I've got to look at pictures, because I'm going to show you some pictures of the clean room. I did a bit of a clean up before the barbecue because I was embarrassed about the state of the place. And then, since then, I've done a little bit more. So I'll show you those pictures in just a second. But, Michael says, I was not barbecue present due to birthday shenanigans. That's, that is, yes, well, I'm sure the birthday was fun. My point was going to be, that will not be the last barbecue. That was basically a test run. I just wanted to see if anybody was interested. And I am kind of surprised at how many people did turn up. It was a bigger success than I expected, which is really cool. And that encourages me to do it again. I have this is probably being rather ambitious, but I have a goal that ultimately I'd like to be able to do one barbecue a month. Maybe that's too often, I don't know. But maybe like first Sunday of the month, barbecue at the Super Lab. And if people want to come up and just have a sausage and leave again, that's cool. Or come and hang around for a while, that's cool, whatever. Just make it a casual thing where I'm going to be here after the stream for a couple of hours on the first Sunday of the month with the barbecue going. And if people want to turn up, that's great. And yeah, that could be a cool thing, and turn it into a bit of a show and tell as well. So last Sunday, a couple of people brought things for a show and tell, including some Funway and associated things, which was really cool, including a Funway Volume 3, which I was allowed to touch but not keep. Clifford. So Clifford says, first time I've joined you. Well, welcome, Clifford. I would have been there, but 900 kilometers is too far. Yeah, it is. DIY says, I come from the south. We make food for at least 200 people at a time. Scaling up. All right, now, yeah, I know that before the barbecue happened, a few people said, please take photos and video or whatever so that they can see what happens. And I didn't. I must admit, I was a little bit... Overwhelmed is the wrong word. I was expecting there to be maybe 4 to 6 people. And so then there would have been time to, spend more time just talking and take a few photos and that sort of thing, but it with so many people here, it ended up being, yes, I just didn't get to taking photos or anything like that, so that's the way it happened. Yes, also, hello Imi, and good job with the soldering last week? Yes, that's right. So last week for the barbecue, Outside the Box and Imogen and Anne both turned up in person and were my backseat drivers sitting behind me for the live stream. And Imi soldered for the very first time, putting together an Arduino kit. So where are we? I'm just looking at what pictures I've got here. No, that is not useful. Where are some photos? Okay. Now, I'm going to open these and these. I've just got to select them and then that one and that one. Okay, open. In just a moment, I will switch over to give you a view of what I'm looking at. Why doesn't that fit? Okay. Alright, so starting from back in time, I think this is chronological. Yes, it appears to be chronological. So let's go gadget pictures. Now, when was it? A few days ago. Okay, so this is, you can see it's kind of a messy floor. This is a view looking in from the roller door. And you can see on the left there is the entrance. That's the door that goes through into the lab. And that door, I'm sitting like basically behind that wall on the left at the moment. That's where my lab area is. And so this is looking down towards the back. And this was after the barbecue. So this was on, in fact, this was Friday night, Friday afternoon, I think. I'm disoriented. Friday afternoon, so this was after the barbecue. We had the barbecue and all the food and stuff set up in here, but since then the barbecue got moved out of the way, and you can see in here there are some big sheets of melamine that were delivered, and then we carried them around. They were large. In fact, that's not even all of them. This was while we were moving them, so there were more that came in after that. So you can see here a few of them. These ones here are 2.4 by 1.8 meter sheets, which I think is, what does that make it? 2.4, it's 6 foot by 9 foot if you're talking about freedom units. And then there were some other sheets that are 3.6 meters by 1.8 meters. So the length of these narrow ones at the bottom, but as high as these ones. Those were the big sheets that we hadn't yet moved by the time this photo was taken. So those are, 6 foot by 12 foot sheets. And this was the start of putting up spacers. So you can see the Dexian racking is in place there. And then I've put some strips of timber across here as spacers because the brackets here from the Dexian beam stick out from the uprights, and also the feet stick out a bit. And so what I did, and these uprights are set back behind the face of these buttresses. So these strips of timber bring the surface out flush with the brickwork here. And then, where is it? There's just another photo of the same sort of thing. Now, one thing that you'll see here is that there is a 4-way power board on the wall. And I'm still going to need to get access to that even when the sheeting is on the wall. So that will become relevant in just a second. This is one of the sheets before, so this is one of the 1.8 by 3.6 meter sheets before it got cut and lifted up into place. Now this was quite an exercise. I don't know how much, in fact I'm going to look this up. Maybe someone else can do it. A weight of chipboard 2.4 meters by 1.8, no, 3.6 meters by 1.8 meters. I have no idea if I'm going to get any results on this. I haven't actually weighed it, but this thing was really heavy. Moving this was not easy on my own. And so yeah, it's quite hard to get a sense of scale of how big this thing is just looking at it like that. But basically the top of this sheet is head height pretty much, and like for even a moderately tall person, and it's very long. So you can see up here I was measuring out the slots that need to be cut so that it can lift up into place and fit around the Dexian beams, and I drilled holes in the corners and then cut down to the drill hole so that it would have nice edges on it. Need the thickness to get a weight. You're right, Aaron. 16mm melamine is what this is. So it's basically 16mm chipboard with melamine front and back in 1.8 by 3.6 meter size. So what I did was chop those little slots out of there, and then because I was doing this on my own, the way I actually did this was, it's a little bit hard to see there, you might see it better in a different view. I set up a block and tackle and lowered it down the back side of the frame from up on top of the mezzanine. And you can see this orange rope here. This is the end of, like the tail end of the block and tackle, which I had dropped down through a hole in the ceiling up on the right hand side. And then it came down behind the sheet, and down here, and just here, you can just see there is a little bit of blue metal sticking out there. That is a cut-off piece of Dexian, which is attached to the end of the block and tackle. And that was acting as like a hook. So it was hooked under the bottom of the sheet. And that way what I could do is pull on the rope. The block and tackle lifted the sheet from the bottom while I was also holding it. And I slid it up into position and then pulled the rope across and wrapped it around the Dexian beams and just tied it off. So it held it up there in position long enough for me to get some chocks under it for safety, and then screw it through. So it ends up like this. Clifford, 96 kilos. I thought it was heavy. It was not easy to move. Thank you for working that out. 24 by 1200 by 12 millimeters is about 20 kilograms, 11 kilograms. Yeah, so that's, so you're working it out based on 12 millimeter. This is 16 millimeter. So it's, yeah, more than a one person lift. It was hard for one person, that's for sure. I can lift it, but it's hard. So, and very awkward just because of the size of it. Oh, second calc is for 16 millimeters. Cool. Thanks, Clifford. Thanks for going to the trouble of figuring all that out. I appreciate it. So 96 kilos was the weight of that sheet. And then, yep, based on 8 kilograms per 0.72 square meters. Cool. So then you can see that since I put it up, I cut this hole out of it, and that is for access to the 4-way power board, which is mounted on the wall behind it. And then I'm going to put something like an access hatch over it to cover it up. Then, oh, you're right, Martin. Bunnings always publish the weight of the products. Yes. Henrik. No, I didn't see your comment. Hang on. So Henrik just sent me €2. Thank you for that. Henrik's strategy for getting my attention is to send me money. So Henrik said, did you see my comment? No, I didn't. Okay, so I'll scroll back, and Henrik's previous comment was, did you see my comment? No, I didn't see that one either. Okay, I'm going to keep scrolling back. Henrik. Henrik says, one module arrived yesterday from China, so I think I can send you a package out next week. Awesome. That is good news, Henrik. Thank you very much. Let me know how. Henrik said, yes, but it works. You're right. That method, getting my attention by sending me money, is a method that works. Yes. Henrik, when you got it ready, let me know, and I will send you money for postage. Thank you. That is very cool. For those of you just tuning in, Henrik has been in the process of putting together a package to send me with some interesting things. And yeah, we've been discussing how to get it to me. So there are going to be some surprises. I don't actually know what's in the package. I just know that it's going to be things that will be probably fun to play with on a live stream. So we will see what happens. Yeah, Michael says it would work on me for the record. Henrik says that was €2 for the next barbecue sauce bottle. Nice, thank you. Where was I? That's right, so this sheet is up. Now, you may have noticed a slight flaw in the plan. This gap right here. What is going on with this? Well, the reason for that is that I'm putting this up in multiple segments. I've got like a plastic joiner strip that will go along here, and then there is a smaller strip that will go in the bottom. And in fact, if we scroll all the way back and we look at this thing here, ta-da, look at this. There are thinner strips there. And that's because the largest practical size sheet I could get was 3.6 by 1.8 meters. And then Aaron says, are we suggesting John is a meat voice puppet to the highest bidder? Yes, that is true. So the strip that is on the bottom is what will fill in the gap along there. And it's going to be below bench height anyway, so down this wall there will be, initially at least, this corner bench is going to be going into this corner, and then there will be a workbench along this wall which will be above that height. So you won't even see that join. That'll go down to floor level there and be sealed up, then the next sheet will go in there. So a more overall view. It's a bit of a mess. I just, for the purpose of the barbecue, what I did was move the pick and place machines into a line, and the Bernie Boy reflow oven was down the end. The cleanish room area was pretty well organized. It was quite neat, and all of the machines were approximately in place, so that people who came to the barbecue could just get an overall view of how it's all going to fit together. But then, in order to keep working on it, I've had to move the machines again and compact them back up towards the front end of the room. Now, Mickle Make It is still in active use. It's sitting there on this bench, and the computer is on the table beside it that's running it, and it's got a chair there. That's because during the week, Tom has been assembling boards, and he's been using Mickle Make It to do that. So that is actively in use. In fact, I think it's even turned on. In fact, if you zoom in under here, look, you can see LEDs peeking out from here. That's an Arduino sitting in underneath it. That's the one that controls the feeders, I think. And you can see that it's powered up. So that machine is actually powered up right now. And I've moved the KO pick and place machines back into this end of the room so that I could have access to do that. So this end of the room is open space at the moment, so I can maneuver these big sheets into place. Since the barbecue, I've also done more work on the frame around the stairs. So the stair landing is now properly bolted in place to a steel frame, and it's all nice and solid. So there has been progress even since the barbecue. I really want to get this space done. It's getting so close now. And once the walls go up, once these wall sheets go up, it transforms very quickly. Yes. Clifford asked, what support will you put behind the join? There is a joiner strip that goes there. It's a plastic molding that clips between the two sheets. And I already have those. In fact, they are... Oh, it's behind my head. Hang on, I'm going to turn myself off. There I go, I've vanished. Down in the right-hand side of the room, if I zoom down there, you can... Whoop, not that. I went too far. You can see this pile of white things. Those are plastic edge strips that clip in between the two and act as a joiner to seal the two sheets together. So the two sheets butt end to end, and then there is like an H-shaped molding that goes between them, and that just keeps them kind of aligned, but it doesn't add much in terms of mechanical strength. It just acts as a sealer and to keep them aligned. And then the bottom sheet is will be screwed into this cross piece here. So, but it's only like 400 millimeters high. That's not much of a gap there. Yeah. Okay. So yes, I could put some more insulation behind there. Probably what would make sense at the very least is sealing at the top of the gap, because this space that you can see here, this cavity behind the wall, that is open all the way up through to the to above the ceiling. So if I stuffed some insulation in along the top, which I can easily do from just from standing up on the mezzanine, I've got access to this wall from above. All of this open empty cavity behind it, it's all easily accessible from above. I can reach down into it. So if I stuffed insulation into the top part at least, it would turn this into like a trapped air area. It would stop circulation, and that would make a difference. Right, yes. Yeah, it's not an external wall. That's right. This is an internal wall. This block wall here is internal. There's there's Lachlan's part of the factory on the other side of this wall. So there was a question here. Oh yes, that's right. So David asked, just a query, why the choice of whiteboard, chipboard? There has been a long thought process that has got to this point. I need to cough already, just a second. Hopefully that's a bit better. Yeah, so basically I'm standing inside a big whiteboard box. Originally I wanted to do this using cool room panels, and the cost of that ended up being something in the region of $7,000 to $9,000 to build the room out of cool room panels, and I would have had problems with the strength of the top, because you can get cool room panels up to a reasonably good thickness and they're fairly strong. They will span a long way, like I can get it to span the 4 meters, but the problem is that the load rating on top is not that great, and I would have needed beams or something across to make it more rigid so that the top could be useful as a mezzanine. And gaining the floor space of that mezzanine has been life-changing for me. Moving so much stuff off the ground level of the factory and moving it up onto the mezzanine has given me space like this. All of this floor space that you can see here, this wasn't possible a month ago because I just had stuff jammed in. There was no room to move. And moving things that need to be stored up onto the mezzanine has then allowed me to keep the important stuff at ground level and then give me this room to move and do this work. So that was one of the reasons I ended up veering away from cool room panels. And there were other alternatives as well. Other things were discussed as construction methods. And in the end, what ended up happening, what finally tipped me over was Lachlan wanted to, so the other side of this white wall at the end of the clean room is a little workshop area that Lachlan uses. There's a workbench along the other side of this wall. It's basically like a U shape and like a mirror image almost of my space. And Lachlan wanted to use the other side of this wall as a screen for a projector. And a good way to do that was just to use melamine and build the wall between our two workshop areas, and then he can use the other side as a projector screen. And This wall went up so quickly and easily and relatively cheaply that I was impressed with how well it worked. And it just tipped me over and thought, yeah, I'll just do the rest of it the same way. It was such a good construction technique. Just panels dropped into place, screwed onto a frame, and you're done. And you end up with a really hard, very easy cleaning surface, which is semi-structural. I can screw stuff into it because it's 16. This whole wall is 16mm chipboard, and yeah, it was good. So, right. Oh, Cable Tie says, I have a video of the sore spot. Can you make me a mod so I can post the link? Absolutely. Well, when I say absolutely, I will try. Cable Tie. Okay, how do I do this? Member participants. How do I add you as an admin? I've done this in the past, and oh, hang on, Cable Tie. Add as moderator. There we go. Standard moderator. Okay, Cable Tie. You are now a moderator. I'm surprised you weren't already. I thought I would have. Okay, so where was this? Johnny said, so you want to be blue instead of green tie? I don't get that. Maybe I've been missing context. Martin said also, can you use thermal barrier, which I use behind my weatherboards, foam and foil with holes? Yeah. Yes, so I could do that. Yeah, I had been thinking about getting some of that, what is it, cisulation or whatever it's called, the big silver rolls, silver on one side, sort of blue on the other rolls, and wrapping that around first, and I ended up just going for it. Aha, Cable Tie has... oh, so that's Johnny's point. It was green equals member, blue equals mod. Yep. So Cable Tie has now just posted a video to the... posted a link to a video of the sore spot. So David asked, what was the original thought for using cool room paneling? Okay, so cool room panels have a few benefits. Firstly, obviously, they are insulating. That's the whole point of cool room panels in the first place. So it means that climate control would be really, really easy in terms of not being thermally leaky. If the room was reasonably well sealed and I put in like a reverse cycle air conditioner, it'd be pretty easy to get the room to a set point and then keep it there. It should be very stable. And that would also provide sound insulation, and it also has a very nice surface because cool room panels have a thin steel skin on both sides, which is like powder coated, color bond sort of finish. So, you know, the same sort of thing that you would get on like the surface of a fridge or whatever. It's a very smooth, glossy finish. So, and it's magnetic, so you can stick things to it, and it's reasonably easy to work with. Like you can cut the cool room panel with a saw and stick it all into place. It's just a really nice way to quickly build a box that is thermally stable and that is semi-self-supporting as well, because the panels themselves can be the structure. They don't need a frame to be attached to. So cool room panels are a good, quick construction technique. It's just that the cost of doing it ended up being a bit too high. I would have preferred it, but yeah, after getting all of the Dexian, well, most of the Dexian stuff that you see here I got free, that was hard to turn down. Right, so I assume I'm talking to myself right now because everybody else is just off looking at sore spot. In fact, I wonder if, let's see this. I wonder if I can, I'm just going to hit mute on my computer. I'm going to open the sore spot video. I wonder if I would get, yeah, I'm going to put this up. Hopefully I'm not going to get any copyright things. I'm going to, hang on, I'm going to pause this. I'm going to bring this video up and full screen that and turn myself off. So this is Cable Tie's video of the source bot in action. So you can see pressing the button, press the red button for source, and the source bot dispenses the source onto the sausage. So where are we? Back to here. And Imi also said, could you link to the soldering iron you used from AliExpress, please? Yes. YouTube Inception, yes. So, where are we? Okay. I will do that, and then I'm going to get on to talking about this board that I'm going to assemble, because it's 10:36. 10:36? It's 1 minute after 10:35. I don't know. Sorry, it just reminded me of that Tiest song, which is really cool. I like it. So, what was I doing? That's right, I'm going to go to Superhouse Gear. I'm going to bring this up on screen in just a second. Here we go. So last week on the live stream, Imi soldered for the first time, and she used my Aishin T3A soldering iron. So I've just dropped a link in the chat to superhouse.tv/gear, and I haven't updated this page for a little while. I probably should. This is a page that talks about some of the equipment that I use, and I've got links to the microscope. In fact, some of these links are probably broken now because I haven't gone through and checked them. A lot of them are links to AliExpress ads, and some of them are probably obsolete now. So let's find out. The main bench soldering iron I use is the Aishin T3A, which is a JBC clone, and it's a really good JBC clone. Oh, look, it's on the going to AliExpress is on the ad blocking list. All right, I'm going to proceed with that. Okay, so this is the soldering iron, and the one that you would want to get. No, don't allow what. It asks me every single time. So obviously you want the 220 volt version if you're in Australia. What have we got? T12, T245, T245B set. Okay. The one you want is not the T12. So there are different hand pieces that are available for these. The one that you want is the T245, which is the JBC type soldering iron, the JBC type tips and handpiece. And in fact, I believe it's even compatible with genuine JBC handpieces and things. So you could, and JBC tips definitely. So this is the one to go for. There is also this, which costs a little bit more. So it's 155 for the regular one, and then if you go for this one, it's 178. The advantage of this is that it comes, this is the, what do they call it? The T245B set. What this comes with is the fancy holder, which is worth it. I like this. I've got 2 of these. So I actually have 2 of these soldering irons. One of them is on my own bench, on bench 1, and bench 2, which is behind me. The other one, the other soldering iron, you can probably, where is it? It's there, that's it. It's just sticking up there. It's out of focus, but that is another one of those Aishin soldering irons, and that one's on bench 2, which is Tommy's bench. And yeah, so I got these fancy stands, and they're definitely worth it. They've got they've got a tip cleaner in the front, and they have a changing system on it. One of the cool things about these soldering irons is that you can change the tips in a few seconds, and it only takes like 4 seconds to go from cold to working temperature. And with the little clip that's in the back of this soldering iron stand, what you can do is put the iron into the stand, into the clip, pull the existing tip out while it's hot. So you're not touching it, you're using the stand to pull it out, and then you shove the handle onto the next tip that you want, and pick it up, and 4 seconds later it's hot and ready to go. So you can change between tips while you're soldering and barely even like pause for breath. It's just, oh, I'm doing a connector, so I need a bigger tip. Chunk, chunk, change, and now you've got the larger tip. Oh, now I'm doing small stuff. Chunk, chunk, change, and now you've got a small tip. So it's, yeah, really, really cool. I like these irons, very good performance. Buffering, oh no, is higher than the recommended. Yeah, there's bad buffering. That's terrible. All right, now, where was I? Okay, so this gear page, just as a disclaimer, these links to some of these ads are affiliate links, which means that for some of them, like if you, whatever this thing is, TS100, I wonder if this tip, this ad is still valid. No, that ad is not valid, so I'm gonna have to replace that link. So the TS100, like if you follow some of these and then buy whatever it is, then I might get like $2 or something from it. Doesn't make any difference to the price that you pay, it just means that there is like a referral thing that comes back to me. So, Uni-T, okay, so things like links to multimeters are here, and oscilloscope and lab power supplies, like these RD Tech power supplies. I really like these. Yeah, lots of good stuff there. So, okay, now, a couple of times I have obliquely referred to a new client that I've been working with just for a little while now, which is heavily embargoed, so I can't tell you who they are or anything they do or whatever, but yeah, it's a really interesting and fun project. And one of the things that they needed me to do was help with characterizing a DC motor that is working in a mechanically dynamic system where sometimes it is working with a load, sometimes it's working against a load. So imagine the scenario being a motor with a gearbox attached to it, which is moving with a worm drive. How is it working? Yeah, so it's acting as a linear actuator and pushing on the end of a lever. And sometimes the lever is applying force to the end of it, and sometimes the lever, like a positive force pushing against the actuator, sometimes the lever is pulling away from the actuator and it's attached, it's on a pivot, so it can't actually move away, sometimes it's pulling the motor, sometimes it's pushing the motor, and sometimes the motor wants to push the arm and sometimes it wants to pull the arm. So you can have multiple situations. You can have a situation where the arm is moving away, like it's trying to move away, and the motor is trying to push it away, so it's barely going to be working. Other times the arm is trying to push and the motor is trying to push it away, so it's working really hard. Sometimes, and this is where things get interesting, sometimes the motor is trying to pull the arm and the arm is trying to push, and what happens is that as the motor comes to a stop, it is still having force applied to it by the arm, and then essentially the motor turns into a generator. So it's like a worst case scenario for back EMF. There is power being applied to the motor in order to retract it and pull the arm down, which is also pushing against the motor. So it takes barely any power to turn the motor, to move it, but then when it gets to the end of its travel and you want to make it stop, there is force applied, and now all of a sudden the motor has turned into a generator and power is being fed back into the system that is trying to control it. And not just a little bit, like many, many amps. It's, and yeah, there are really big spikes. Oh, cable tie. You had 17 views and no likes. I'm sorry, I will stick a like on your video, but I won't open it again now. Celtic Beast says we won't tell people it's Elon. No, no, it's more interesting than that, more exciting than that. Tony says, commonly called a 4-quadrant DC controller. Lifts and cranes are a typical application for these controllers. Yeah, Clifford says, this is what I'm here for. I want to attempt to sense motor back EMF to count commutator segments instead of fitting an encoder. Yeah, I don't know if what I've done so far is going to help with that, but maybe we will see. Yeah, so the thing is, the controller that is doing this, the controller that is moving the motor is a high-end. These people are sparing no expense. The particular application for this, I was going to say that cost is meaningless, but of course cost is never meaningless. There is always, yeah, but this is a situation where the idea of, sticking a $900 motor controller on this means nothing. It's like you don't even think twice. So it's, the motor controller that is driving this system is really, really nice. It's very, very good. And it's, all the smarts built into it that you can imagine. So it's got, all the adaptive PID stuff to deal with the varying load profiles and things, and CAN bus interface and all of that sort of stuff. So controlling it is not the problem. The motor is dealing with the mechanical scenario just fine, and it is meeting its power profiles, like in terms of the force that it applies and the acceleration and deceleration that it can apply to the load that's exerted on it, etc. So what that load actually is doesn't matter. But what we needed to do was characterize how much power is being backfed into the system when it is in that worst case scenario of moving with the direction of force and then stopping and then turning into a generator. So that is what I started messing around with. Now the thing is that measuring current, I've measured current in different ways many times on both AC and DC circuits over the years. And the way that I would typically deal with a situation of measuring current on a DC motor, so a simple DC motor driver, like H-bridge type arrangement, is with a current sensing chip, something like one I've used quite a lot is the INA 260. I've also used other variants like the INA 219. And there are others. So the INA 260 has a built-in shunt, so it's got a very low value resistor, and what it does is measure the voltage drop across the resistor, and you've got a known resistor, you've got a known voltage, therefore you can calculate current. So very simple sort of stuff. And but it does it in a neat way. It's got an I2C interface, so you can just talk to it and say what voltage you're seeing right now, what current you're seeing right now, and get readings out of it. Which is, being over I2C, it's not necessarily extremely fast in terms of number of samples that you can do per second, but for most situations it's fine. But the issue is, I'm just wondering if I should draw a little diagram of that. I think I will. I'm going to try. Okay, I'm going to grab that and maybe go to that. See, I've got a bit of crappy looking cardboard here. Now, need a pen. All right, so the traditional arrangement, I'm looking for my field of view here. Let's see, we've got V in coming in here, and we got, well, I'm going to call it ground, 0 volts, whatever terminology you want. So the way you would normally do this is that you would run this through a current sense device, something like an INA 260. Could be on the high side, could be on the low side. I'm just going to show it on the low side here. And then we have an H bridge. I'm not going to bother with all the internals of that. And then the output of the H bridge goes to the motor coil. And then we have a spinny thing over this side. So what happens is that we have current flow, conventional current. Let's not get into conventional current versus, you know, electron flow and all of that sort of thing. Let's just say we have conventional current flow coming in from the positive side. It goes through the current sensor across the sense resistor, goes into the H bridge on the positive side. We have a 0 volt connection for the return current coming here, and that's negative side. And then the H bridge supplies a differential across the motor. It could connect both of those outputs together, which applies motor braking essentially, or you could have positive on this side and negative on this side to make it spin one direction, or you could make it negative on this side and positive on this side, make it spin the other direction. So the H bridge allows you to either cross the outputs or to send the outputs directly through with the set of 4 MOSFETs typically that are used in the H bridge. So this is the bog standard, really common way to arrange something like a motor driver with current sensing. Now the thing is, we are sensing here on the input side going to the H bridge. And if you use the H bridge to retard the action of the motor, say you are going into a braking stage, what will happen is you have a magnetic field that is built up in the coil here of the motor, and then that coil will try to collapse, which then induces a current, which if these two are joined together in the H bridge, say it's gone into motor braking mode, so it's joined those two together, the current will try to discharge through the H bridge as the field here collapses. So that is what we are trying to characterize. But the current is being measured up here. So how do we measure the current that is generated as the field collapses in the motor? Sorry, I had to cough again. Now, if you are only ever spinning the motor, well, no, that's not even going to work. So the possibly obvious but incorrect way to do this is to take this current sensor and stick it here. But the problem is typical current sensors can't deal with bidirectional current flow. And there are many that do, and that's exactly what this project is about. This is what we're going to do. But you can't use something like an INA 260. Like the really commonly available sensors have a positive side and a negative side, or a current in and a current out side, and you can't backflow them. They would have a bit of a heart attack. They need to have the potential difference positive on one side and negative on the other, and if you connect them backwards, really bad things happen. So you let all the smoke out. So it's not as simple as taking a traditional current sensing chip like an INA series chip and putting it on the output side. If you do that, you will get good measurements as you are driving the motor because in one direction, because the current will be flowing in that direction. But then when you turn the motor off, you will get a big back EMF spike. So what happens is, if we've got a chart that looks like this, so we've got time on this, and we got voltage here. What will happen, and say we've got, this is the 0 point here, 0 volts, and then we've got positive voltage there and negative voltage there. So if we are running the motor, say the motor is not running, there will be no volts across it. So we're talking here about measuring voltage there across the motor coils, across the motor coil. So we've got 0 volts and the motor is not running, and then we apply a positive voltage. So the voltage that we were measuring would go up, and then the motor is running, and then you turn off the power, you disconnect the power through the H bridge, and then the voltage falls. But it doesn't just fall to 0. What happens is that it overshoots, because there is energy here in the motor windings, and it has to go somewhere. So it overshoots. You will then end up with a negative voltage measured across the coil, and then it'll dissipate and then go back to 0. So we get this. In fact, it doesn't quite look like this. It actually looks like a spike up. If we're looking at current flow, this is the kind of profile. We get a, so say this is not voltage, say this is current. It follows this same sort of profile. So we get a current spike, we get inrush current, and then the inrush current drops as we get to a steady state and the coil is saturated. It then has a constant current, and then we get a negative current value as it flows in the opposite direction, and then it comes back to a steady state. So that would be if we're measuring current, so I, at a point in the circuit here somewhere. Anyway, that's what we're trying to do. What is the chat saying? I haven't been looking at this for a while. Right. Oh, interesting. Clifford said, Jerry at Devon Tech published some excellent 4QD drive circuits. This was his primary expertise before he retired, as well as designing the SRF08 and SRF04 sonar units that are so widely cloned. That's very interesting. Thanks, Clifford. I'm going to have to check out Jerry at Devon Tech. I haven't heard of Jerry at Devon Tech. This is one of the reasons that I do this. It's because I am kind of fuddling my way through this, and there we go. I just stuck it into a Google search, so I will look that up. I'm just muddling my way through this and figuring it out as I go, and doing this talking about this sort of thing on streams brings out everybody else's expertise, which is great. I get a chance to learn. Yep. Yeah, Andrew Cochran says, at a Ford factory, if a contractor stopped the line, they'll bill $25,000 a minute. So spending dollars on high-end gear is not really a factor. Yeah. Yep, 25 grand a minute. All right. Now, where are we? Oh, Stephen W says the INA 219 just gives a negative current if you go backwards. That's interesting. I didn't know that it was capable of doing that. That is really cool. Oh, Clifford says there is no braking from a short circuit. Very little energy is dissipated because the motor has a low DC resistance compared to its inductance. That's not how 4QD controllers work. Ah, okay. Interesting. Going on, I'm just jumping chat comments here so that I'm following Clifford's explanation, because he is a much smarter person than I am. It says the short circuit is applied until the motor current builds in the loop inductance, then flipping the H bridge to route that current back into the supply, battery, etc. Right. Perhaps better to chat offline about this. Yeah, could be. Thanks, Clifford. So, oh, Aaron says, I miss the good old whiteboard days. Bring it back in the form of the entire clean room walls being your canvas. Yeah, I could do better, big diagrams there. Okay, so what I did was last week I did this. So this is a breakout for a what is it? It is oh yeah, and someone in the chat said use a hall sensor input. Yes, that's exactly what we're doing. Gerald, that's right. Gerald42 says a hall effect sensor. Yes. So this is an ACS 712, and the just wondering if I'm giving away any. No, I'm not. That's good. So INA 712. I was just checking that I wasn't doxing myself by showing the DigiKey label, but I don't think I did. There's that is the Hall effect current sensor. So this module here, it's an extremely simple breakout. It's an ACS 712 with a couple of capacitors on it and a screw terminal, and that's it basically. This is a breakout for this current sensor chip, which is a Hall effect sensor, and then I've got it linked in here. Now the output of this, this Hall effect sensor runs on 5 volts and it generates an analog output. The analog output is centered on 0 volts. Sorry, it is centered on the supply voltage at 0 amps of current. So if supply is 5 volts, the output will be 2.5 volts if there is no current flowing. And then it goes up if current flows in one direction, and it goes down if current flows in the other direction. So then what I did was, there is a little voltage divider on here. It's just made out of surface mount parts, so it's too small for you to see on this camera view. So it's 5 volts and ground going to supply the sensor, and then a couple of resistors there as a voltage divider to drop it down to the 1.1 volt voltage range for the analog input on an ESP8266. So there's the Wemos D1 Mini with an ESP8266 in it, which only has a single analog input, and it has a maximum input of 1.1 volts. So that's the reason for the voltage divider. Anyway, so this is the prototype that we used last week. I then did another one that was a step up from this, and now I've got this, which will turn it into a form that hopefully will be a bit more convenient than, you know, jumpers and random stuff lying around on the bench. So my goal is to make a little ESP32 based current sensor, and I'm going to put, because everything I have is, oh look, it fits, amazing. I've used these footprints before, so they're already verified, and use XT60 connectors on it so that I can just plug in whatever loads I want, plug in whatever power source I want, and measure current. So thanks to Gerald pointing out that the INA 219 does bidirectional current sensing. I didn't actually know that. Maybe I should have done this with an INA chip instead. Might have worked out better, but oh well. This is where we are now. And this is just a basic DC gear motor that I was using for testing my original prototype, and we will see if that works. So what am I going to do first? First I'm going to grab myself some gloves. Because I shouldn't be showing too many bad habits. I know, I do. I show all the bad habits. That will be for cleaning the solder paste in just a second. So I'm going to, I didn't get a stencil for this because this is just like this is not really a real project. This is just a messing around thing. I was ordering some other PCBs anyway, and the thing is that I don't even need this anymore because we've already done the measurements using the other cobbled together thing. But I just thought that it was an interesting thing to do, so I'm going to hopefully that's clean. Microscopy, and unfortunately my microscope is still doing its stupid flickery jiggery thing. Let's get some magnification happening and some focus happening. I think it's about there. Yeah, I didn't, let's see, is this solder going to flow? Yes. I didn't bother getting a stencil for this, and it's one of those trade-off things where, yeah, I could have got a custom stencil with no, and yes, I know this pad's not even connected. Could have got a custom stencil with no frame, but then it's a lot of messing around. And I'm probably only ever going to assemble one of these boards anyway, so who cares? For an extra 2 minutes or something putting on solder paste by hand with a syringe, it's not really worth it getting a stencil made. Now this is the point where I need Chip and Immy sitting over my shoulder reading from the chat, because I'm staring through the microscope, can't see the chat, got no idea what you're talking about, and normally when I'm doing this sort of thing, I do something like put a podcast on and just listen to that while while my eyes are otherwise engaged. So what is this part? Oh yeah, this is the it's a CP2102 USB to serial converter. What have we got here? Oh yeah, activity LEDs. Oh, look at this. These are the they must be the 5K pull down resistors on the USB charge lines for USB-C. Just stick some solder paste in there. I'll manually solder those stakes anyway to mechanically attach the USB-C connector. But if I put a bit of solder paste in, then it ends up giving it a bit of initial attachment at least. What is this? Oh yeah, this is the sensor chip. This is the ACS712 sensor chip, and you can see here the high current paths in and out. Is that it? Yes, I think that's the solder. That's all the solder paste for the board. See, that wasn't too painful without a stencil. Now I need. Imogen says lots of interesting things going on in the chat. I haven't seen any of them. All I saw was that comment saying that there are interesting things going on in the chat. Now, oh, Paul said, I'm also looking at an ACS712. I have code for ESP32. Oh, cool. Yeah, I've got code for it running on an ESP8266, so I'm hoping that I just have to recompile. Maybe change what am I doing? Maybe change the calibration values. Can't think. All right. I'm just pulling up the design so that I can see what parts go on where. Now, where are we? In fact, it's probably worth having a quick look at this anyway. So this is the board layout, and let's have a look at the T values. Where are T values? T values there and there. Okay. So schematic. How messy is my schematic? Yeah, it's not too bad. This one's, it's okay. All right, so this is, funny thing is that the majority of this schematic is the USB to serial converter. We've got USB to serial converter coming in here, so that's a CP2102N. Then we've got auto reset circuit. There is an AP2112K, which is the 3.3 volt voltage regulator coming off 5 volts. So this requires 5 volts to operate. It can't be powered off the target load. It's got no ground reference or anything on it. So it's just 5 volts coming from USB. There's a poly fuse there, so USB 5 volts comes in, goes to the 3.3 volt regulator. Then we've got just a Vroom module, because it's easier to throw down a module than to do the discrete parts, particularly for a one-off board like this. And then I chucked ignore the current sensor for now. I chucked a button on there, just onto IO35 with a pull-up resistor, because there's no internal pull-up on IO35, and a button, mode button. Don't know what it will do. I just included it because maybe we'd need it as a calibration input or something. And then the current sensor. So it's an ACS712, and we've got the XT60 connector coming in on this side. And oh, actually I should have kept that. No, that's okay. I was just thinking I should have kept that totally isolated from the device, but nah, oh well. So what I could have done, what I'm getting at here is, this is the inside connection for the load, and that's the outside connect. Well, that's the inside connection for the power source. This is the outside connection for the load, and in fact, it doesn't even matter. You could connect it either way; it would make no difference. So, apart from positive and negative readings. So what I've got is the low side, so the 0 side is connected to ground on the board. I could have just passed this straight through here, I think, with no interaction with the board, and that might have been a cleverer way to do it. Have a bit of isolation, but I didn't. Oh well. So we've got the ACS712 with its 5 volt power supply. We've got current positive and negative side. It kind of makes sense. These labels here are just the pin labels from the data sheet of the ACS712, so I'm not sure. Like I is obviously current. P, I don't know what that stands for. So out, we've got an output here going to a voltage divider, because we've got a 0 to 5 volt output range, and we want to scale it down to a 0 to 3.3 volts. So we've got a 2K2 and a 3K3, and that will scale it down to a full scale of approximately 3.3 volts. And then it's going into IO34, which is labeled as the sense input, and which is back on here. Here we go, IO34, sense, right there. And that's it. That's it. It's just an ESP32 with a voltage regulator, a USB interface, and a current sensor, and a mode button. That is it. So now I need to put some parts on. What am I going to stick on? Alright, 1 nanofarad, 100 nanofarad, and stuff. I haven't, as you can see, the designators are all over the place here. Normally what I would do is normalize the sizes of all these designators, of all these values, and I would rotate them all to put them into nice positions, so that it's nice and easy to see. So yeah, I normally have it, I don't know how other people do it, but the general rule I go with is to have all the values and designators so that the text is horizontal, except in extreme situations, and ideally you want the label to be directly above the thing that it refers to, so that just for consistency. It's one of those things like coding standards. You know, do you want to do all your curly braces on the the trailing end of the line, or do you want them on a new line? And people have strong opinions one way or the other, but if you're working in a project with other people, it actually doesn't matter what you use as long as everybody does the same thing. Just have a convention and stick to it. So the convention I use is, where's that one? AP, yeah, that one's going to have to go underneath it. That one is going to have to go up there. So we've got a couple of protection things there. So the general rule I go with is that I stick the value or the designator above the part and oriented so that it can be read without rotating your head. Now in some situations where you've got parts that are close to each other, you do have to break those rules, but at least then you're breaking a rule. You're not just... Anyway. Oh, there's a 10K down there that I didn't normalize the size of. Let's do that. Boom. There we go. I love the Stream Deck macros in Eagle. So, yes. I think it was Karen was asking at the barbecue last weekend. Karen was asking about the streaming setup, like the cameras and how the Stream Decks are set up, and the ATEMs and things like that. And so I was showing some of the way that's set up. So I've got a Stream Deck profile for Eagle. So when I have Eagle in the foreground, the Stream Deck shows a whole bunch of shortcuts for doing different things. So I can do tool selection, and I can do things like turn single layer mode on and off. This is just me pressing a button on the Stream Deck, and you can see it's toggling between single layer mode and multi-layer mode. Yeah, the useful stuff that I do all the time, like say group. So now I've got the group tool, and that's the move tool. And you can see the toolbar at the top is changing, and that's because I'm just pressing buttons on the Stream Deck. So I don't need to go to the menus. I can be focused in on something and be switching modes just with my left hand, just tapping away on the Stream Deck. Well, here comes the rain. You probably can't hear that through the microphone, but it has just started bucketing down here. All right, so what was I doing? All right, I'm going to start putting some parts on in a second. What is going on? Hush on the eyes. Oh, not flashing. You're under my control. Okay, yes. Yeah, the flickering microscope camera was hard to watch. Yeah, I'm going to stay away from from the microscope just for a little bit. I'm just going to put parts on without the microscope. I'm just going to do it. Where is it? Where's the camera? There's the camera. I'll just do it here. So the ACS 712 chip comes in a few different varieties, and it has different current ranges. So this is a 45 amp version. There's a 20 amp version. This is a 30 amp version that I pulled off a breakout. And here's a 5 amp version. So I'm going to put the 5 amp version on this, but we will get to that in just a minute. Now, oh, I had this on the bench as well. So this is a breakout for an INA 260, and it could be that would do the job as well. But anyway, we're here now. We might as well continue. What do I need? What do I need? I need my favorite tweezers. A little bit battle scarred, as you can see. I need my jumbo box of miscellaneous resistors, and let's start with that. What do I do? I'm going to put down, this is going to be tricky to do without sticking my head under the camera, but I will do my best. And if I do stick my head under the camera, you can all yell at me in the chat, and I will ignore it because I'm not even watching the chat. So what do I need? A couple of 5K resistors. What is that one? Then we got what, a couple of 1Ks. So it's when I'm doing assembly like this that I need to see the chat. This is when because I don't really need my brain to be doing this assembly. It's just, I'd be better engaged looking at the chat. So what do I need? 47K5, where is that? 47.5K, here we go, 47.5. Yeah, I need to do something about my microscope. It's got some kind, well, I don't actually know what the problem is. I've had a brief look at it and have not come to any satisfactory conclusion. And in fact, I can't really cause it to fault. Like, it looks like some kind of a bad joint type thing, which is making it flick on and off. But I've done things like tapping around on different parts of the board, and I can't make it trigger. Like, I can't make it respond in any sort of useful way. What have I got here? 10K and 10K. And what else do I need there? There's another 10K over there. That one, that's the pull down on the mode button, which mounts on the other side of the board. Then I need another 22K. I was just doing those a moment ago. Another 22 goes there. And a bunch of caps, but before I get to that, all right, so the voltage divider is up here. So I need a 2.2, oh, interesting. I don't have a 2.2 in my little kit of parts here. I might have to pull one of those off a reel. All right, do I have a 3K3? I have heaps of 3K3, and that one goes there. So that's a 1% 3K3, and I need a 1% 2K2. Then, BitLooney does text-to-speech in his streams. Don't understand how he can focus with that in his ears. Oh, interesting. Maybe I should try that. So another 10K up there. Why is that one 10K? That seems like a very excessive value, because that is the current limiting resistor on the power LED. I'm going to go 4K7 instead. There we go. 10K is probably okay, but anyway. All right, so I've got that, done that. I think that's it for the resistors, apart from the 2K2, which I'm going to have to go and seek out somewhere else. Might have to pull one out of a reel on the pick and place machine. But in the meantime, out comes the trusty capacitor set. And what do I need now? I need a bunch of 10 microfarad 0805s. Here we go. All right. The usual thing, sprinkle some of these around like confetti. Where's the voltage regulator? That's it. Okay, so I'm not even looking at the overlay now. I'm just going by guesswork. My guess is that the two capacitors on either side of the voltage regulator are 10 microfarad. Now, what else do I need? Nope, don't need any more 10s. I need some 100 nanofarads, I think. Oh no, I need 100 nanofarad there and a 1 nanofarad there. Is that camera focused? It doesn't really look very focused. I'm going to mess around with the focus for a second, which is going to make it zoom way in. And there. That looks better. And in just a moment it will jump back out again. So then, yeah, so that one is 100 nanofarad. All right. 100 nanofarad there. Going back to that thing about BitLooney using text-to-speech in his streams, I kind of like the idea of you having a co-host on this. having someone else sitting here and making it more of a, well, in this sort of situation it'd be really useful. So that was a 1 nanofarad that I just put down. What else do I need? Are there any more caps? Oh yes, there's another 100 nanofarad down there. That must be on the, what is it on? Reset line, maybe? Could be. Any more parts? Oh yeah, those two up there, what are those? Oh, those are the protection Xeners that go on the USB line. So I've got those around somewhere. They, I think, are in my diodes box. Should be somewhere in this, I think. Yes, USB protection. It's a PGB 1010603NR. So 2 of these go onto the USB line. I also need to make sure I've got a CP2102 handy somewhere. I haven't assembled any boards with those for a while, so come on, try to turn it over, and it ended up back the direction that it started. Alright, so protection, and oh yes, and I need the fuse that goes on there as well, the poly fuse. Okay. Now, rather than packing up as I go, I'm going to leave a mess behind me. Polyfuse. That one? Yeah. That one will do, I think. Yeah. Stick that fuse in there. Yeah, so I'm going to end up with a big pile of anti-static bags and things on my bench. Alright. I'm going to put on the 5 amp version of the current sensor, because what we're going to be doing in a minute is testing this with this little DC motor, which does not pull a huge amount of power. Like, it's in the hundreds of milliamps region. It's not like a big high power multi-amp motor. So the 5 amp version of the sensor should be just fine for us. Now, what else do I need? CP2102. Oh, yeah, there are a few more things I need. I'm still some distance away from being done. Feels like you're done when you've got the resistors and capacitors on, because that's the majority of the parts. But in fact, now we're down to the point of all of the individual things. So I need a dual transistor for the this thing for the auto reset circuit. Of the ESP32, so that it can be put into bootloader mode. This thing, come back here. That goes on. Actually, I'm going to switch to the microscope. I'm not going to switch your view to it, but I'm going to put this on under the microscope. And then, oh, it looks like there are a couple more parts. What go on either side of that? I haven't been looking at the overlay. I need another 22K and a 1 microfarad. Okay. I am not done with the resistors and capacitors. So another 22K goes on to the right of the dual transistor. And I need, what is it? 1 microfarad. No, not 1 nanofarad. 1 microfarad. Where is 1? Do I even have, what? 1 microfarad. Why do I not have 1 microfarad 0603 in this collection. I've got, yeah, that's strange. I've got 0805, so I wonder if that'll fit on that footprint. Let's see. Let's see if I can stick an 0805 on an 0603 footprint. I'm just doing this under the microscope because I want to see how bad it is. Yeah, that'll be fine. It's fine. Look at this. Microscope. Sorry about the flickering, but there you can see an 0805 capacitor sitting on an 0603 footprint. All right, I'm going to get you back away from that view so that you don't go crazy. Now, CP2102, let's get that one next. Those things are a bit of a pain. One of the things that's annoying about them, sorry about all the rustling, is that you have to load a profile onto them. You can't just stick them on a board and have them work out of the box. You've got to open Simplicity Studio and load, come on, yeah, and load up a profile, like tell it to be a USB to serial device and what pins it's using for what. We'll get to that. What's the time? 11:30. We've only got half an hour left. Okay, I'm going to do this one under the microscope as well. Which way around do I have it? That way? Okay. So we may actually be pushing for time to get anything useful by the time this is reflowed. I shouldn't have spent so much time at the start just chatting. So I need the button, I need the USB-C connector, and I need a voltage regulator. So we're getting close. Oh, and up there I need I need LEDs. That'll be easy. So I need one of these reset buttons. That can go on there. Then I need connectors. There's a USB-C connector here. Oh, and I can't forget that I still need to grab that 2K2 resistor. So this is the USB-C connector. There we go. Yes, I need the 2K2 resistor going onto the voltage divider to stick on there. Okay, so regulators is next. I'm kind of rushing now because I've run myself out of time. Okay, I need an APE212K. Yoink. Once I stick this into the oven, I will then have a couple of minutes to hopefully catch up on chat and see all the feedback. So, what have we got? LEDs. Let's do LEDs next, just to get them out of the way. Which LEDs do I have? I don't have any blue. Got plenty of green. Let's just make them all green, because it doesn't actually matter. I'm going to go that way. So power LED is going to be green, TX LED green, RX LED green. Now I've just got to check under the microscope again because I'm not sure which way around these ones go. I believe it is current flow, TX, RX. I actually can't see. Silkscreen isn't helping me. I'm going to have to resort to looking at the overlay. And it goes that way. Current flow goes that way. Okay. I think it's like this. Come on. I'm holding the LED backwards. That way. And that way. All right, so TX and RX, we've got that there. Those are in place. Power LED is done. I just need the ESP32 and the 22, the 22K resistor. So I'm going to stick on the ESP32 first. I have that in a box somewhere. Where is my box of room modules? Here we go. Oh no, I already got one out, that's right. That was the the only bit of preparation I actually did before the stream, was I grabbed out a room module. So that is ready to put in place. I'll grab some different tweezers. Joink. And how are we doing? 22K, that's the last thing. All right, I'm gonna go for a little walk out to where the nickel maker is, into the cleanish room construction site disaster area. And do I have, yes, I've got a whole reel of 2K2s here. Okay, so I can pull one out. Here we go. Here's a 2K2 1% resistor. Stick that one on there. And I'm going to, just a final quick once over. Have I got everything? Have I missed any parts? I don't think so. Looks like everything is populated. So I'm going to stick this in the oven. That ESP32, is that aligned? Oh, close enough. Close enough for government work. So let's let it do its little bakey thingy. So I'm going to bake this in the old oven. Going for a walk now. So I'm going to bake this in the old oven because, as you have seen, the the oven is full of boards. I just opened the reflow oven and it's full of boards from the last batch that were done that hadn't been taken out yet. The Bernie boy is currently unplugged and shoved up against the end of the room. So I'm using the old reflow oven, which is the T962C, running the Reflow Master Pro, and that was its wakey beep that you just heard. Reflow, go! There's new firmware available, but I'm not doing that now. Alrighty, I'm going to leave that to its business and come back in a while. Now, what is everybody up to? What is up, YouTube? What's been happening in the chat? Right. Stephen, I'm just... oh, Sion's here too. G'day, Sion. So I'm just jumping randomly back in near the end of the chat. The first thing I read was, not all ground is 0 volts, Stephen W says. Yes, that is correct. Not all ground is 0 volts. The regulator that went out, where is the... Oh, Johnny says, where is the auto reset circuit? Is that... Oh, maybe... This is probably talking about other things. Probably not even talking about the the thing that I'm building. You look to have the DC jack connected. Oh no, yeah, this is all talking about Austin's stream, I think. So it's not even what I was doing. I just scroll way back. Johnny, greetings, Sion said, just John waffling about for an hour before he got the PCBs out. Yep, that's pretty much it. What else have I missed? Buffering, not a real live stream. Okay. All right. Harsho said, why is the board so big? The reason it's so big is just that it didn't need to be any smaller. All right, so if I switch back to this view, what I wanted to do was make it so that it was convenient to use in like a nice little enclosure. So this is just a cheapy plastic enclosure from SZOMK, which is my favorite Chinese random case supplier. I just happen to have a bag of these. And so what I did was design the PCB to fit this enclosure because it's just like a nice small enclosure. It looks probably pretty big on stream there, but that's just because it's zoomed in, and you can see from my hand that it's actually quite a small case. So the PCB is designed to fit in here. In fact, I haven't even verified this. I pulled these out of the bag earlier and assembled the first one and have not even tested whether it fits in. Oh look, it does. Screw holes are not quite aligned, but close. So the idea is that what I'm going to do is cut slots or holes in the side of the enclosure for the XT60 connectors to come out, and for the USB port on the side here, and screw it in, put the cover on, and it's also designed to be upside down. So what I was keeping in mind is that when this is in use, this is actually going to be oriented like that. So the USB port will be on the left, the in connector will be on the left on this face, and the out connector will be on the right. So I want it in on the left and out on the right. When you turn this over, that is the inside and that is the outside. So this PCB is going to be upside down when it's all fixed inside the enclosure. So yes, this PCB could have been made smaller. As you can see, there is a fair bit of space around it. I mean, this whole thing could have been compressed to probably half the size if you really wanted to. But we're dealing with big connectors and things that, like, it just doesn't matter. So no reason to make the board any smaller than it needed to be. It's just, it is the size that it is. It fits the enclosure, and it should be a convenient sort of device. So my goal with this is to make the device, this was what I was doing for prototyping purposes, and this is what we used to measure some of the motor current on the test rig. Well, this was the first one, then I made a second one with an ESP32. No, I didn't use an ESP32. What did I use on the second one? I can't even remember. Maybe it was an ESP32. I think I might have done it on a Lolan 32. This just shows how bad my memory is. It was like a week ago. And then, but this sort of thing is not great in a test environment because you've got, you know, connectors and then cables that can come loose and things. What I want to do is make this a closed box just with connectors, power in, power out, monitor for USB, and that's it. And then once you unplug everything, it's nice and robust and reusable for different purposes. I did consider putting an LCD on it, and in fact I briefly had an LCD connector here in the design, and then I took it back out again because I decided that I was overthinking it and putting too much effort into it when this is not something that I really care about. This was just like a throwaway, let's do this as a little test thing. And the idea of then having to write code to do the LCD in a useful way, it's, yeah. Sometimes you just have to say, it's not necessary, so don't do it, because it would have just added more time to laying out the board and figuring everything out, and I just needed to get the job done. So this is just all I'm doing here is making a robust version of this. That's it. My goal is not any more lofty or, oh look, I'm picture in picture. Yes. Auto reset for programming. Yes, Johnny, there is auto reset for programming. There is, if we go to this view, that's what this MMD T3904 is for. This is a dual NPN transistor. And switching across. Okay, I'm going to need to take a drink. Just a second. A drink of the strangest stuff on earth. Okay, I've got to get this and show it to you because this is bizarre. I think it was like a week or two ago, I was in the SPC factory, food factory outlet in Bayswater, and I got this. It is Turkish Delight cordial. And it is as bizarre as you would expect. It's kind of delicious and also kind of freakily strange. It's yeah, it really is. The way my son described it, it's like you've got Turkish Delight and chucked it in a blender and then you're just drinking it. It's yeah, I like it in a very strange way. Oh, Cable Tie says I have that, yeah. And Sion says, yum, 1000% sugar. Yes, now, what was I doing? That's right, so auto reset. So we've got the USB connector over here with all its usual bits and bobs and jibs and jobs going across to the CP2102 over here. And that has the TX and RX going to the ESP32, but it also has DTR and RTS coming up to this dual transistor circuit here. So you can see here there are two transistors. These are actually in one package, even though it appears as two transistors here in the schematic. And then we've got a couple of resistors, and then that goes to the reset and GPIO 0 line. So that is the auto reset and boot mode control of the ESP32 from the USB thing I'm a jiggy. Oh look, you can see in my notes here, in fact, you can tell what this was copied from. Can anyone guess? So what I did when I was working on this, when I started this, was I just duplicated some board files from another project and then started ripping and rerouting, and yeah, in the schematic, yeah, I edited a couple of things. I edited the name and the version and that sort of thing, but I forgot to edit my pin allocation list. So yes, there is the clue. There you can tell what this project was copied from. Yeah, Cable Tie says, for those not from Victoria, Yakandanda is a real place. It is, and the name is so fun to say. Yakandanda. Well, Cable Tie, you don't have to go all the way to Yakandanda. You can just get it from Bayswater. The food factory outlet in Bayswater had it. It did as of a week or two ago anyway. Now, I should probably go and have a look at what's going on. I'll leave you with a view of the 3D printer out of focus in the background. And it looks like reflow has finished. So let's see. Yes, it says reflow done. Am I going to burn myself picking up the board? Probably. That is the traditional thing to do. So, time to... board is done. Time to have a quick look at how messed up it is. Now, I'm actually going to look at this under the microscope because I need to be able to inspect this properly. I've got a couple of solder bridges on the 2102, so I'll fix those. A couple of solder bridges I can see on the USB-C connector. I'll fix those. And the ESP32, yeah, I think I might touch up a couple of the pads on that, although it's probably fine. Yep, okay. So I'm going to, sorry to everybody who has a voice assistant with this particular name. Alexa, turn on bench 1. Yes. Okay, so what tip do I want? Not that one. I will go for the K tip for this. What can I do about this microscope? I think I just need to buy a new microscope camera. So I'm going to switch to it, but everybody who has a problem with this, please look away now, because it is it's kind of annoying. Let's just put a little bit of flux on here to help make a bit of a mess. And get the soldering iron up to temperature. We'll just remove those solder bridges from the QFN. Okay, that'll all be good now, I think. So, although it looks just down there, I'm not sure if that pad is actually joined. Okay, I'm going to stick a bit of solder in there and just make sure that we do have I don't even know if that pad's used. Yep, now it's joined. Okay, now we've got some solder bridges on the back of the USB-C socket, so a bit of flux in there. And grab out the trusty solder wick. And let's just clean this up a bit. Now, is that fixed? Looks like it might be. Okay. I think it's fixed. Doesn't look like there are any bridges left. What else? Now, there is a ground connection here on the ESP32 that looks like it might not have flowed, although there are multiple ground connections, including a big ground pad on the bottom of the Vroom module, so I'm sure it doesn't matter. Everything else looks kind of okay, I think. So, next thing is to move some stuff out of my way so I can get to a USB cable and fire up Simplicity Studio. Stephen W says this flux doesn't look yellow enough. Yeah, I've got a couple of different fluxes here. No, I'm going to switch away from that. Go to that camera. I've got a couple of chip quick fluxes. The one I was just using was this one, which is my preferred flux, SMD 29130cc. I think the 30 is actually literally the cc's. It's the size of this dispenser. So it's SMD 291 is the type of the flux. This is another chip quick flux, another no clean tack flux, NC 191. I don't like this because, well, it doesn't flow very well and it stinks and it makes lots of smoke. This stuff is better. Yeah, anyway. Where are we? Stephen says alignment of the ESP looked a little wonky. Yes, and maybe a solder ball in between pins on the USB connector on the right. Let me have another look at that just before I plug in the USB connector. It could be that there's a solder ball. Oh, you might be right. Yes. Let's come back to here. So, Aaron, I think what you might be referring to is there. That looks like there might be a solder bridge there. I think you're right. Now, I've got to move this microscope back because it's the reason you keep going out of field of view is that it's in an awkward spot for me, working off the edge of the bench. All right, let's hit that with a bit more of the solder wick and see if that little spot goes away. I think those are pins that are not even connected. They're not connected on my board, There we go. That looks better. They're not connected on my board, but if this was plugged into a USB-C to USB-C cable, maybe that would be a problem. All right. I'm about to plug this into the computer that I'm streaming from, so this might make the stream end. Hey, we got a power LED. Exhibit A. All right, job is done. It's good enough. Ship it. So next thing is I need to fire up Simplicity Studio and oh, what? Oh, thank you so much. You know, I really dislike Simplicity Studio because this sort of thing happens. The application Simplicity Studio can't be opened. Studio quit unexpectedly. All I was doing was opening it. I have a feeling, I have a feeling that it is broken on that machine. Where is my laptop? The other laptop, not that laptop. Did I even bring it? Surely I brought my my laptop this morning. Funny thing is, actually, I think it might even be still in the car. All right, here we go. I am going to go for a walk out to my car to grab my backpack, and we'll see if I can keep talking to you the whole time. So I've got to go outside. It's a pity I don't have that mobile camera working, or the but it doesn't run on the Mac Mini. To do this, I'm also going to need, I've got to go back out to the car because there is another cable that I need. And this is a really annoying requirement. The book has USB and if I could. And the board that we've just assembled has USB-C, but I can't use a USB-C to USB-C cable because reasons. So what I have to do is get a USB-C to USB-A cable and then use an A to C cable. How silly is that? But thank you to the USB consortium for putting us in this ridiculous situation. The things you have to do to make USB work. All right. Just making sure you can't see my hands because I've got to type my password. All right, so Simplicity Studio. Is it not installed on this? Oh, I have a feeling that it is not installed on it. Okay, let's really test things. I'm going to try running Simplicity Studio on the laptop that is currently running OBS for this live stream. Ooh, living dangerously. Hang on, I probably can. I'm just thinking about whether I can, that means I will be able to bring Simplicity Studio up into your view. I probably can. But I need to unplug. What do I need to unplug? I need to unplug Ethernet. This is kind of this is kind of tricky. All right, I'm going to unplug network from the computer that is running OBS. It should still be okay because it's also on Wi-Fi. But yeah, okay, I'm not going to try to. Oh, look, it's seen it. Hang on, I'm going to drag this onto, no, I'm not going to. It's all getting too complicated. So what I'm going to do is I'm just going to flash it you're not going to be able to see it, but so changing things around so that you can see what I'm doing is going to take longer than necessary. So done, programmed. Nice. Okay, so I now have this device set up with a there's now a profile loaded on that CP2102. So if I plug this into my so this is now plugged into the desktop computer. I should be able to load some code on it. So let's see if I can find the code that I was using last week. And we may even get as far as doing some testing. It's already time for the stream to end, but I don't care. So close. It should really be as close as solder on a couple of connectors, connect the power and the load, and run the code, and that's it. We should be able to see what's going on. So I'm keeping this off your view right now while I find this. Lolan32, there it is. So there is the source for the other project. Yes. Okay. All right, now I can bring it back into your view. So this is the code. Yeah, it was a Lolan32 that I was using for the second version, which was already an ESP32, which is good. So this code can probably just load straight onto it. So let's try port. Do we have a port? We do. All right, no. The last thing I flashed was a SON-off. ESP32 Arduino and its ESP32 dev module, and the port has come up, which is nice. That's it. Do your thing. Change profiles. Take half an hour. Okay. So port is USB serial 0001, upload speed, etc. That should all be able to stay the same. Let's just upload and see what happens. See if it uploads. If this uploads, I will solder the connectors on, and then a few minutes from now, yeah, we should be measuring current. Probably uncalibrated, but at least seeing some pretty charts or something. Yes, Amanda says lunchtime. I know. Paul Barton said Kratos returns. This. Yeah, I actually shaved about 3/4 of it off 2 days ago. It was a lot longer up until Friday. Yeah, it's kind of weird. It uploaded. Cool. All right, now let's just have a look at the serial console. And what we're getting is a stream of values, and those numbers don't really mean anything very much right now, but because this is all uncalibrated, let's go to, where are we? Tools, serial plotter. Yeah, so look at that. We're getting values coming back. That's raw and averaged values coming out of it. So let's hook up some connectors. I'm going to unplug it. Change back to this view. So far, it seems to be working okay. We've got comms, we've got the ESP talking to us. What do we need? I need to put a mode button on there. I need to put those on there. So let's go for, which way is it? That one goes on there. This one goes on here. And for this, I'm going to switch soldering iron tips again back to the big beefy tip. I want that tip. Okay. So should be up to temperature now. I should have done the mechanical ones first, I know. Look at all that smoke swirling around. Yes, I know. I need to get a quiet fume extractor so that I can run it while I'm doing streams. Okay. Mechanical mount's done. Come on, what's going on with this? Because I got a weird angle view on this because I'm trying to keep my head out of the way. I can't actually see what's going on. Oh yeah, those joints are good. It looked like it might have just been sitting up. Yeah, I need to get a bit more solder onto this connector as well. There is solder because of the paste that I put in, but you can see that the, well, maybe you can't really see. You can see that there's a little void in the areas where the stakes go in. They will be soldered, but not as strong as I would like. I want to make it really strong, so I'll probably add a bit of solder to that. Mode button, I'm not going to bother putting on just yet. I will do that. So the idea is, once it is in this enclosure, come on. Once that is in there, the mode button goes on this side of the PCB, and I've used a 4.5mm tacked button because because the body of it is thin, and it's thinner than the height of these stakes, which means that if I just drill a hole in here, the button will then be able to protrude out through the enclosure. So when you're using this, there will be the USB on the side, power connectors there, button there, which will be like a 0 button or something, I think, for calibration purposes. And so let's now just try this. Simplest way to do this is, oh, here we go. So this is power coming from my lab power supply. I'm just going to set that. Okay, V set 12, go. I set 2, go. So we've got 12 volts, 2 amps set coming on this. It's actually turned off right now. The output of the power supply is turned off. The general plan is power goes in here, and then this motor is going to be connected to the output. Other way, sorry, because it's upside down. That's the input, motor goes to the output, and then we are going to log stuff off USB. Now, to connect this, rather than put a connector on it, so I've got a connector here, I could just solder this on, but the quick and easy way to do it is I'm going to grab one of my existing XT60 cables with a with alligator clips on it. So so it's XT60 to alligator clips. Alrighty, so XT60, this is the output side. I'm going to try to arrange this so that it's kind of visible what's going on. Now we've got input going to this side, other way, that way. Output going to that side. I'm going to drag across the USB cable, which is on a long USB extension, so it'll reach anywhere in the room. So USB plugged in. Then the motor I am going to connect to this, which is the output side. And it doesn't actually matter which way around I do this. Makes no difference at all other than the direction that the motor is going to spin. So now, this doesn't have to be in the field of view. Effectively, the important thing is that this motor is connected to the output. We have the lab power supply going to the input. And there's a bit of tape on there just so that you can see it spinning. I'm just going to turn on the power supply and it'll just make the motor spin. Cool. So now we have power going to the motor through the current sensor. In here, out here. And then we have data, hopefully, coming out of the thingamajigamy here. So if I come back to that view, in fact, what I'm going to do is go to the plotter. Tools, serial plotter. All right, now I'm going to turn the motor on and we'll see what happens. Whoa, look at that. Aha, how cool is this? So when it's auto scaling on the serial plotter, which is why it's jumping around like this. But when I turn it on and off, you can see there is a big spike of current when the motor turns on. What I'm going to do is take a, how am I going to do this with these reaching across? All right, I'm going to try to take a screenshot at the exact right moment. But first I'm going to turn myself off. Oops, no, I want that view with myself off. And I want to maximize this. Okay, I think we're just about ready. Here we go. I'm going to turn the motor on, then off, and then take a screenshot. Did the screenshot work? I don't think it did. What is the screenshot in macOS? I normally use Control-Alt-4 to capture an area. What is it in Mac screenshot? Command-Shift-3. That's what I did. I pressed Command-Shift-3 and I didn't get a screenshot. At least I don't think I did. Command-Alt-5. Shift-Command-4. Yeah, Shift-Command-4 lets you select an area, and I need to do it very quickly. So Shift-Command-3. Yes. All right. Shift-Command-3. All right, here we go again. I'm going to turn it on, off, and then screenshot. No. I'm just experimenting with different keys here to see if I can get a screenshot happening. Why? Yeah. Maybe it's just that it's not appearing on... it's probably doing it. Oh, it is doing it, I think. Let's see. That and that. Sorry, the reason that you're seeing that is that, hang on, I'm just going to switch back to the front camera again. What is going on here? That. Oh yeah, okay. So the screenshot was working, it just wasn't popping up on my desktop to show me that it had taken it. So I'm just wandering through 12, 11, is it that one? No, it's not that one. Is it that one? Oh, that one was a little bit late. Okay, but now at least the process is there. Okay, we're going to go back to here. Oops. And back to here. And I'm going to try it again. So, is it that? Or is it that? Yes, okay, cool. All right, now that I've finally figured out how the very complicated thing of how to take a screenshot on a Mac, let's do this one more time for science. So on, off, screenshot. Did I get it? Did I get it? Let's see. Is it this one? Yes, here it is, finally, finally. I worked out how to do a screenshot on a Mac. Look at this. The interesting thing is that the numbers actually even kind of make sense without calibration. But with some calibration, this could probably start being even more useful. All right, so what we're seeing here is the current sitting somewhere around 0 until I turn the motor on, and then it zoomed up. Aaron said you could just play your own stream and rewind. Yeah, that's true. I could capture different points of it. So then the current jumps up, and according to this scale, which this is with the calibration factor from the little test rig that I did a week or two ago, it's not necessarily accurate for this device. It jumped up to, looks like about 800 milliamps, which is, that's about right. That's about what I would expect for this motor. and then after the initial inrush current, it drops off and it looks like it's pulling, I don't know, like 100 milliamps-ish, give or take, for a while. And then I turned the motor off, and you can see it dropped down to here and went negative. So we have a negative current flow here. So this is the back EMF. Essentially this portion, oh, you can't see it because my face is in the way. Get my face out of there. So this portion of the chart right here, what we are seeing there is back EMF. That is the power coming back out of the motor and being dissipated. So yeah, and then it goes back to zero. So this is after power has been removed from it. Well, now the actual purpose of all of this, what got me into this in the first place, is trying to figure out the energy. And this area that I've selected, if you know the voltage, so what we're looking at here is just current. And if you also know the voltage, then you can calculate power, and it kind of becomes the area under those charts. Wow, there are lots of blues in the chat. Okay, we have a chart. It works. I think it just needs a little bit of it just needs a little bit of calibration, and this is, and also obviously I need to cut the enclosure. But what we are seeing here with this chart is cool. Also, the reason that there are two, you can see that there is this very spiky blue line, and then there is a slightly less spiky red line. That's because one is the raw instantaneous reading, and the other one is a rolling average. So it's a little bit smoothed. If we look down on this part of the chart, you can see that the blue is jumping up and down, the red is slightly smooth. It's not smooth a lot. I think it's a 4-value rolling average. Let's find out. What have we got? Back in the code. Yeah, here we go. So 4 milliseconds between readings and 4 samples in the buffer for the rolling average. So we've got 2 libraries in use. There's ACS712, both by Rob Tillart, and running average. There's also, Rob's done a couple of very handy statistical libraries. There's also running median that he's done that I've used a bit. That's a very useful library. And yeah, Johnny says, total success, ship it. Yes, we have seen negative current. And there's, what have we got? So yeah, these are just some mess around values that I was using to do the calibration. So this is using Rob's library for talking to the ACS712, and you can see the, what is this? 3.3 is the voltage range, 4095 is the number of bits on the analog input, so that's used internally in the library for scaling factor. 34 is the pin that it's connected to, so it's IO34 on the ESP32, and 185 is a scaling factor based on the number of millivolts per amp. So you can see here that for the 5 amp version of the sensor, which is the one that I put onto this board, it outputs 100, it varies its output signal by 185 millivolts per amp. And so what we do is we pass in the scaling factor to the library. So if, for example, we were using a 30 amp version of the sensor, then it outputs 66 millivolts per amp. And the library needs to know that, obviously, so that it can give values coming out that make sense. So we've got, we're passing in 185 because it's the 5 amp sensor. We're setting up a buffer just with four samples. Just for the fun of it, let's samples to average. Let's make this 20 and upload it again and see if that ends up being a whole lot more smoothed off. Probably will. So what it's doing is just when it starts up, it sets the auto midpoint. Now this is a trap, and this is the reason that I added the calibration button to it. If you power this up while there is power on the load, it sets the it sets the 0 value as whatever it is seeing at the moment that it starts. So because we're calling this function, which is the auto midpoint function, so what I was thinking of doing was in the loop adding a thing to read the button, to detect button presses, and if you press the button, then it'll call auto midpoint again. And that basically gives you a way of being able to reset the 0 value once this is connected up and powered and running. Raining pretty hard, says Chip. Yes, it is. It is. It absolutely is. It's pouring down now. So what have we got? 0 offset, scaling factor, sample buffer add, and then it's just outputting. And I'm using a very simple delay as well. I'm not even using like scheduling or anything on this. It just waits for 4 milliseconds, which is not taking into account the time required to do the serial output and all of that sort of thing. So this really should be doing it based on a timer or something. Now the reason that 4 milliseconds was chosen is that the data logging coming off the rest of the system in the test rig that my client has set up is all based on a 4 millisecond sample interval. So this is just giving us approximately the same sample rate as the rest of their instrumentation. So that's right. I was going to see. Some Call It Fun says recheck which parameter you changed to 20. Sample. Yes, you are absolutely right. All I was doing was changing the. Sample period won't make it smoother. Yeah, that was a brain fart moment because I was talking and not really reading and not paying attention, and also both those values were 4 to start with, so that was kind of deceptive. If my my samples to average hadn't been the same as the interval, I probably would have picked that up, but I didn't, and thank you for noticing. Okay, so that is now reset. Let's go back to where are we? Serial plotter. Oi, why did that just freak out? Serial plotter, come on. Oh, there it is. It has opened up down on my other monitor, and let's drag it. Oh no, there. Drag it up to be. Come on. That's what I want. And so let's, yeah, you can see that the blue is very jaggy, the red is much more averaged. So if I do it now, that looks a lot smoother. See, the red is a lot smoother now. So I'm going to do screenshot a Rooney in just a second. Did I get that screenshot or did I not? I did not. So let's do that again. And where is the screenshot? Is it that one? Just taking this off here for a moment. Not that screenshot. Is it this one? Yes, okay. So I'll bring this one up where you can see it. There. All right, so now you can see that the red line is much smoother, and it is also obviously lagging the blue values. So now, yes, I did flash it, Keith. So you can see the jaggies for the instantaneous readings, and then the smoothed average of the red line, which is now based on a 20 sample rolling average instead of a 4 sample rolling average. But it's doing its thing. So I think we can declare this a success. I still have some work to do because I still need to, well, I still need to do that. I still need to do some construction work on the clean room. But I also need to do the, oh, interesting. Sorry, distracted by blinking lights. In fact, I'll show you what I was distracted by. Look at this. I just glanced across and I saw this. That's the USB activity, the serial activity, as it's reporting back all the values. So I need to cut slots in the enclosure and mount this in it, and put the button on there, the calibration button. But it's basically done. Like, it's functional. That it's V1.0 of a PCB, and it worked. And so far, it seems to be working exactly as expected, which is a little bit mind-blowing. Michael says, given that it's 12:25, has Pete exploded or just left the chat? I think he may have exploded. Yeah. So today's stream has been sweet success. We're on a roll of winning at the moment. The barbecue was a winner. That was so cool. Thank you everybody that came along to that, and I'm sorry that not everybody can make it because of geography, pesky geography. But I'm gonna have more, definitely. It was. I was saying to someone, I can't remember who. Someone I was talking to afterwards about the barbecue. It's kind of unusual because normally when you have that sort of event, you have a lot of people who know each other. It's like a social group sort of situation. And when I say know each other, I mean having met face to face. The thing is that there were, 25-ish people, as I said before, who came along to the barbecue. Very few of them had ever met anyone else face to face from that group. I'd met quite a few of the people that were there face to face, but many of the people who came along were YouTube viewers who I've never actually met before, so they were coming along to the Super Lab for the first time. So I got to meet people for the first time, which was great. But yeah, it can be really daunting. Like going into a social situation where you don't know anyone, and the only person that you kind of vaguely know might be me, just because you've been seeing me on live streams and you've never actually met me before. So yeah, coming along to something like that can be outside of your social comfort zone. It's not the sort of thing that I would be really jazzed or comfortable about doing. And so thank you to everybody that did and had a chance, that I got a chance to meet. It was really cool. I really enjoyed it. But as I was saying, because it was a situation where almost nobody knew anybody else, that can kind of make it awkward. It can be difficult to overcome that barrier and initiate conversation and get things going. But from what I saw, people had a good time, and everybody was chatting to everybody else, so it was good. I'm going to do it again. And maybe next time I'll have the IP cameras coming into the ATEM, and we can do some video or something from the barbecue. There is definitely going to be another one. I think I'm open to feedback on this, but just for simplicity, I think first Sunday of the month is probably a good convention to settle on. If that is okay with people, then let's do that. Yeah. Oh, Mr. Fixer said next time you have one, do a Zoom for the people who can't make it in person. That is a good idea. So something like some way, like a Zoom meeting, where people can join in, or Jitsi or whatever, you know, one of those tools. We can have a laptop set up with the camera and everything, and whoever is here can walk up to it and talk to the people who are on the chat, and we can have other people in the chat. That is really cool. In fact, maybe I could even set up a projector. I've got a couple of old video projectors here. Yeah, some way to have people from out in internet land come in and interact. That would be really cool. I like that. Yeah, Mr. Bixit says, if you do Zoom, a lot of people could come together. Yes. Michael says, I will consult my ADHD and see if that schedule suits. Cool. Yeah. So, thanks for coming to the stream. It has been a stream of success, and may you also experience a week of success until we meet again for more success next week. You're all awesome. Go and make something awesome. Bye.